Dear students, last class we have seen two-dimensional close packing, right? Today we are going to see three-dimensional close packing. So in three-dimensional we are going to study HCP and CCP. HCP is hexagonal close packing and CCP is cubic close packing. Remember this one? This both the packing, it is coming from two-dimensional hexagonal packing. Okay, so basic form is two-dimensional, so both are arises from two-dimensional hexagonal close packing. So first one, this is the first layer. What I have drawn this one here, this is the basic layer. Okay, base layer, that form base layer. Now, so how it is arranged, you know, already we studied in two-dimensional hexagonal close packing. The first row, this one, second row lies in the depression of the first row, then third row, first row and third row is similar. Okay, this is a base layer. Now what we are going, you see here, when we are drawing this one, there are two types of voids arises, right? What are the voids? To differentiate, the first one A, I have marked like this. Okay, second layer is B, so sorry, not second void is B. So A, all B. Every voids are triangular voids, right? Now what we can do? We have to arrange other layer on that one. Second layer is placed just on first layer. So you see here, I am covering all this B. So first one B here, this also B here, this also I am covering B. Next one here also B, this also B. Students, are you seeing this one? This also B, this also B. Okay, so first voids are A and B. The voids appear in first layer, base layer. Base layers are termed as are marked as A and B, small a and small b. Okay, now I have placed a second layer on that one. If you see the second layer, you see you are getting, after placing first one, this one, second one, placing or staking, placing second layer on B voids. So what happened, this one, you are getting other next arrangement. So in this one, after placing this one, you are getting different types of voids. You see here, this voids, let us give C. This also you can give C. Okay, this void also C. Now you see here, the voids, this is new voids has arrived here. So what is happening here? Here we have taken only small portion. It goes on extending three-dimensional. So it goes here, it goes here, it goes here, it goes here again. That height comes like this one. So the void C, here void C. So I have taken only two voids. Okay, this void C and this void C. That is actually what you can tell which one. That is tetrahedral voids. So voids C. Voids C is tetrahedral sides. You see void C. So if you observe this one, voids, what is this? What is here? Here one sphere, here one sphere, here one sphere. So this void appears here. So this void comes after placing the second layer. So this is simple voids. It arises after placing second layer. Okay, now next one, you see the voids A, you see here. You are seeing the voids A, this void. Here also voids, already we had made the void from first layer. You see the voids A already from first layer. Then after placing second layer also, the same void is there. What does it mean? The voids which appear in the first layer coincide with the voids which are placed in the second layer. So this voids X here this one, this marked one, no asterisk sign. These voids, you observe this one, these voids are octahedral voids. Third one here, which one? Fourth one, voids mark like this one. Okay, these are octahedral voids. Octahedral voids. Okay, so first one, if you observe properly, here what is here, which one? Then suppose here you see, if you can observe properly, you see this one, students, this sphere I am taking this sphere. Can you see this one? Only we are taking this sphere. If you take this sphere, you see this is tetrahedral void, this is octahedral void, this is also tetrahedral void, this is octahedral void, then this also tetrahedral void. So if you take a sphere, around this, if you take this sphere, around this there will be 3 tetrahedral voids and 3 octahedral voids. Sorry, this is tetrahedral voids. This one is B. So 1, 2, 3. The B voids are what is called tetrahedral voids. The asterisk sign, this sign marked as this one star sign, that shows that is octahedral voids. Is it clear? Okay. Now how many layers over? First layer, first layer is over. Then we have placed second layer. Now how we are placing depends upon, we are getting HCP and CCP. So you are just imagine 3-dimensional, you are getting different voids. One we call it tetrahedral void, other we call it octahedral voids, right? So if we are arranging or placing or stacking next sphere means third layer on tetrahedral voids, it gives you hexagonal close packing in 3 dimension. So what you can, this one first layer is, we are marking first layer A. Next layer we are marking as B. Next layer, what we are saying, this is the first layer, this is the second layer. Third layer you are placing, where you are placing, this is the tetrahedral void. So you are placing on this one. Okay, so that layer, sorry, here you see here, this one, this is tetrahedral voids. This tetrahedral voids exactly come on the first, similar to first layer. So the A structure, and next one, what is coming here, which one? B structure. Okay, then what comes here, which one? A. So A, B, like that it goes on coming like this one. So first layer, then second layer, then first layer again repeated, these are aligned, these are aligned. Okay, so first one, when you see this one, the C is tetrahedral layer, not this B. B is tetrahedral, this tetrahedral voids, this B already exists in first layer. So remember this one, not B. If you are placing that third layer on C voids, so fifth one, placing third layer on C voids, exactly it arranges, it comes on, it comes or it repeats the first layer, it repeats the first layer, it repeats the first layer. Okay, so A first layer, then B. Third layer also similar to A. So A, then B, then AB. So we can write here AB, like that it goes on repeating. Okay, once again I am repeating. First we are placing the first layer. From first layer we are getting 2 voids. Those voids are small a and small b. Okay, it is given the name. Next, what we are giving among these voids, very important point you see, you can keep the next layer on either on A or B. Very important point is, at a time you cannot cover A, you cannot place the sphere on A and B simultaneously. So either you have to place it on A or you have to place it on B. So where I have placed on B voids. So it gives the second layer. After placing the second layer, we are getting new voids. These new voids only we have given names such, what is this one? C voids and asterisk sign. Then if you observe the C voids, what is happening here? That is simple. That is actually simple void, that is tetrahedral voids. Okay, so two types of voids are coming. One is C, another one, for your understanding, I have given the sign, this one asterisk sign. That is actually what is coming here, C voids and asterisk voids. Okay, then if you are placing, so second layer also over. Then third layer, if you observe this one, you are placing the third layer exactly on C. You are placing the third layer exactly on C. So what happened if you see this one? Suppose you are placing here exactly on C, that third layer and the first layer repeats again. It repeats the first layer itself. So this type of arrangement is called AB, 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 this one. Okay, next one. This is the hexagonal close packing. In hexagonal close packing, let us see, in hexagonal close packing also, three-dimensional cubic close packing also, the volume of packing efficiency for both, it comes 74%. Okay, what it comes 74%. Now you see here, we are seeing tetrahedral voids and octahedral voids. So here packing efficiency in hexagonal close packing is 74%. Packing efficiency is 74%. Okay, now what is the coordination number? Coordination number is equal to 12. How it comes? Suppose for example we take normally 1, 2, 3, 4, 5, 6, 7. So we are seeing this sphere. Okay, so here how many are there? 2, 4, 6. On that other 3 it comes. Suppose for example this is a first layer. Then you are arranging on that one. So here is one here, 2 here, 3 here. Okay, this is actually the layer, the sphere which we are seeing here, this sphere. So 6 spheres, what the coordination is? Coordination number is 12. So 6 spheres on same layer. Okay, next one. 3 spheres above, next layer, above. And same thing, suppose this is here, 3 here, same way you get 3 balls or 3 spheres below that also. So total how many spheres are touching this one? 6 spheres on its own layer, 3 spheres on top of that one, and 3 spheres below this one. So 3 spheres above and 3 spheres below. So we get coordination number is equal to 12. Okay, next one we are going to see the CCP packing. In CCP packing, what is here in CCP packing? Here which one? We are placing the first layer is same, then second layer is B, then third layer we are placing on octahedral voids. Octahedral voids. Okay, so when you this layer is something different. So see, third layer in HCP, in C cubic close packing, first layer A, first layer, first. Next one, layer B is second one. Okay, here students listen here, in cubic close packing, So already we have seen the first two types of voids. One is tetrahedral voids and octahedral voids. Now what we are going to do this one, we are placing layer C on what, which one? Octahedral voids. Okay, octahedral voids. Octahedral voids. So remember this one, the third layer is completely different from first and second layer. Different from first and second layer. Okay, the next one, third layer over, next one, fourth layer comes that one. So wherever you are placing that one, wherever voids are coming, you are placing on the voids, right? So first layer, then first layer voids, second layer voids, what is coming here? New layer. Second layer, you get octahedral size. So you are placing the third layer on every octahedral voids, right? Then after that, then again you are placing the fourth layer. So fourth layer is similar to first layer, similar to layer A, first layer. Okay, so how it comes here? First A, then first you are taking A, then you are taking B, then C, then A, then B, then C, like that it gives. It repeats that one. So what you can this one? A, B, C, A, B, C, A, B, C. Okay, in this is cubic close packing also, coordination number is 12 only. You see, in three-dimensional hexagonal close packing and cubic close packing, maximum coordination number it can be 12 only, right? It cannot be more than 12. So here coordination number is 12. Next one, this cubic close packing, it is also a face-centered cube. It is a face-centered cube. Face-centered cube, that means FCC. So how will you draw this one? Suppose when we are drawing this one, cubic close packing, so we are drawing like this one, this is normal cube like this one, 1, 2, 3, 4. Okay, next one, this face one, here corners. Okay, next one, here one face, this also one face, this also other face. Okay, so if you see this one over here, the top layer 4, then this layer also if you see 4 will come, this layer also if you see 4 will come. So coordination number is equal to 12. Packing efficiency is equal to 74%. Just we have seen then how to calculate packing efficiency in different cubes or unit cell we'll study later. Okay, so this is three-dimensional close packing over. Example, I think, see, if you have doubt or something, no, very beautifully in NCERT text the colorful diagrams are given. Page number I think 15, the structure hexagonal close packing AB is repeated here, and cubic close packing ABC it is given, and it's very important to study the example also. In example, if you see here in cubic close packing, copper and silver crystallizes in cubic close packing. Okay, then hexagonal close packing, magnesium, beryllium, the magnesium and zinc and beryllium, they crystallizes in hexagonal close packing. Okay, then next class, next video we can see different types of voids. In voids how the atoms are arranged. Okay, thank you.